Okay, in lesson 7.2, we're going to look at some things that we've done actually in the past. In fact, back in section 4.1, we classified triangles by their angles and by their sides. But whenever we would classify triangles by their angles, we would always have an angle somewhere to let us know what the biggest angle was. Well, let's take a look at this triangle here. And let's say that it has side lengths of, say, 5 and 7. And let's call this one down here 10. All right. Now, we don't know, is this going to be an acute angle? Is it going to be a right triangle? Is it going to be an obtuse triangle? Well, in section 1, we looked at the Pythagorean theorem. We said, okay, we take the hypotenuse, which is always the longest side, but it's only of a right triangle. You take that side length and you square it, and then it's equal to the sum of the squares of the two legs. Well, what if we take something like this and we compare the biggest side compared to the sum of the squares of the other two? Because, see, we don't know. We don't know what this is yet. So I'm going to go through and label, and I'm always going to label the biggest side C. Just like the biggest side in a right triangle is always referred to as C, we want to do the same thing here, and then label the two other sides as A and B. Now, so long as you have the biggest side to be C, it doesn't matter for the other two. But let's just say C squared. How does that compare to A squared plus B squared? I don't know if it's equal. I don't know what goes inside this blank, but that's what I want to find out. Well, in this case, we have 10 squared. How does that compare with 5 squared plus 7 squared? Well, as you can see, the 10 squared is 100. 5 squared is 25, and 7 squared is 49. Now, the 25 plus 49 is 74, so 100 is definitely greater. And because it's greater than, this is an obtuse triangle. What we're saying is we don't know this measure right here, but we know that it's greater than 90. All right? If C squared is greater than the sum of the squares of the other two, it's got to be 90. Well, so let's take a look at what this shows us when we have a comparison between the two. And this is what we need to know. C squared, we have 3 options. First option, second, third. C squared, if it's greater than A squared plus B squared, if it's equal to, or if it's less than A squared plus B squared, the sum of the squares of the other two legs. So again, 3 options here. Coming back to this, then our 3 types of triangles are, well, in the case of greater than, it's obtuse. In the case of equal to, it's right. That's the Pythagorean theorem. And if it's less than, that's acute. So the middle one going straight across, C squared equals A squared plus B squared, well, that is a right triangle, right? And let's make sure that nobody thinks of that as a minus sign right there. I'm just pointing to that A squared plus B squared. But if you go on the top root up here, C squared is greater than A squared plus B squared, then it's obtuse. If you go on the bottom root, C squared is less than A squared plus B squared, then it's acute. And that is what section 7.2 is completely about. Let's take a look at the guided practice on the bottom of page 435. and it's just asking, tell whether a triangle with the given side lengths is a right triangle. We want to do more than that. We want to find out what type of triangle it is by its angles. All right? So let's take a look at this first one. 4, 4 root 3, and 8. Now these are going from smallest to largest. The 4 is the smallest, the 4 root 3 is the medium side, and then 8 is the largest side. We want to compare 8 squared to the 4 squared and the 4 root 3 squared. Well, the 8 squared, that's easy, that's 64, that's our multiplication tables, as well as the 4 squared. But now this 4 root 3, we've got a couple of numbers being multiplied inside. Because there's no addition or subtraction inside the set of parentheses, we can bring the square that's outside into both of these and write 4 squared times the square root of 3 squared. Well, we'll bring down the 64 and the 16. And now then, this is 4 squared, that's 16 times, well now if we square a square root, well those undo each other. Those are inverse functions. So we have the 3. Or if you want to say you square the 3 underneath, that's the square root of 9, which is also a 3. Well, let's take a look at this. 16 times 3, that's 48. And if we add the 16 up here plus this 48, we get 64. So how does this longest side squared compared to the sum of the other two? That's equal, which means this is a right triangle. All right? Take a look at the next example. This has side lengths of 10, 11, and 14. Again, small, medium, large. So I'm going to take the largest side on the left, and it always goes on the left by itself. How does that compare with the 10 squared and the 11 squared? Well, 14 squared, this is not in our multiplication tables, but it's not too far beyond. This is 196. Now the 10 squared and 11 squared, these are from our multiplication tables. So these should be very quick to write down. And what we have is 196 compared with 100 plus 121, or 196 compared to 221. Well, that is definitely less than. Because it's less than, this is an acute triangle. The biggest side, when you square it, if it's less than the sum of the other two sides squared, that's going to be an acute triangle. Well, let's take a look at the last one. This has side lengths of 5, 6, and root 61. Now, we're assuming that root 61 is the biggest. How do we confirm that? Well, what are some perfect squares that we have that we know? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So the square root of 36 is equal to 6. The square root of 25 is equal to 5, and this is the square root of 61. All right? Anytime that you want to compare numbers to see which one is bigger, and you've got radicals involved, these roots, put them as the same root. Now then, if you look at root 25, root 36, and root 61, all you've got to look at is the radicand underneath each one, and you can see that that root 61 is bigger. So I'm going to take the root 61 and put it over here on the left by itself, squared. How does that compare with, and now I'll just use the 5 and the 6, with those squared. Well, what do you get when you square a square root? Well, you get the radicand, 61. Again, those are inverse functions of each other, so they undo each other. And over here, we have 25 plus 36. Well, again, I need to add these two together. So adding the 20 and 30, that's 50. 5 plus 6 is 11, and so this is 50 plus 11, or 61. Well, again, how does 61 compare to 61? It's equal. So what kind of a triangle is this? It's right. And we know this. We know it's a right triangle without knowing any of the angles inside. It's just by looking at the side lengths. This is what this entire section is about. We want to go through and find what kind of angles, what is the biggest angle in the triangle. Not that we know its measure, just which one is the biggest, if it's less than, greater than, or equal to 90. On the bottom of page 437, it has the summary of this entire section, and each one of these theorems is one of these c squared greater than, equal to, or less than forms. So if you look at those three, that's everything that we've done in this one.